The types of chemical reactions. Look around. Are there signs that a chemical reaction has taken place in your home or in your community? Are there indications that it transpired, and are there new substances formed or decomposition of constituents happening? It is said that a chemical reaction has taken place when some of the following indicators are met, such as formation of gas and or precipitate, change in color and temperature, production of new odor, explosion, and the like. Even though there are millions of limitless and unbounded chemical reactions that are possible, they can be classified into one of its five basic types. Analyzing the substances involved in each reaction will also help you to place it in one of these categories, although they may fit into more than one category. So the five types of chemical reactions are the following. You have the synthesis reaction, decomposition reaction, single replacement reaction, double replacement reaction, and the combustion reaction. So we will discuss each of these one by one. So let us start with the synthesis reaction, which is also known as combination reaction. It is when a single compound is formed from the combination of two simple substances, mostly elements. The general formula for the synthesis reaction is you have the element A that reacts with the element B, which are your reactants, will yield to your product AB, which is a compound. So for example, to produce sodium chloride, sodium metal reacts with chlorine gas. So you have to notice that in the equation, that chlorine is written as Cl2 because it is existing as diatomic molecule in nature. Six other elements also exist in the same manner, such as hydrogen, nitrogen, oxygen, fluorine, bromine, and iodine. The second one, or the second type of chemical reaction, is the decomposition reaction. So the reverse of synthesis reaction, and it is when two or more simpler compounds are the result when a single compound breaks up. In most decomposition, reactions input of energy such as heat, light, or electricity is required. The general formula for decomposition reaction is the the compound AB, which is your reactant, will yield to your product, which is will decompose into an element A and B. For example, when both elements or components of the binary compound are the product of its decomposition, is the simplest of its kind. For example, your mercury and oxygen gas are the products when the red solid mercury 2 oxide decomposes. So when one or more of the products is still a compound, it is also considered as decomposition reaction. For example, a metal oxide or the calcium oxide and carbon dioxide gas are the products when a metal carbonate or calcium carbonate decomposes. Okay? The next one, the third one, you have the single replacement reactions. So it is when in a compound, one element replaces the other. And the general formula for that, we have the compound AB that reacts to element C will yield to element A that reacts to the compound BC. In this general reaction, the lone element A in the reactant replaces the element B in the compound BC. Thus, forming compound AC and element B ends up alone. Remember, in the process of replacement, a metal element must replace the metal in the compound. The same rule applies for nonmetals. For example, many metals reacts with acids. When it happens, hydrogen gas is one of the products of the reaction. So if you try to look, zinc reacts to two molecules of hydrochloric acid, which is an aqueous solution. That yields ZnCl plus your hydrogen gas as your product. Okay? And the next one, you have the double replacement reaction. So it is when two new compounds are formed when two compounds react. So in a double replacement reaction, the reactants are generally substances in aqueous solution that dissolved in water and neither a solid precipitate, a gas, nor a molecular compound such as water is one of its products. And the general formula for double replacement, we have the compound AB that reacts to the compound CD will yield to a compound AD that reacts to compound CB. So, in this general reaction, A and C have replaced each other while B and D do the same. You have to remember, in the process of replacement, the metal in a compound replaces the metal in the other compound, and the nonmetals do the same, thus having a double replacement in the reaction. For example, the reaction shown happens when potassium iodide and lead to nitrite, both in aqueous solution, are being combined. So this is the example. So the last one, you have the combustion reaction. It is when carbon dioxide and water are the products when the simplest group of organic compounds, hydrocarbon and organic gas reacts. Oxygen, O2, must always be on the reactant side. It is the main indicator that a combustion reaction has occurred. And the general formula for this, you have the C sub X, H sub Y, or your hydrocarbon that reacts to oxygen will yield to carbon dioxide plus water plus the heat and light, which is the product. So that makes it a combustion reaction. For example, because a massive heat energy is released during the combustion, many hydrocarbons are used as fuels. So in the example, commonly used fuel source in gas grill is from the gaseous hydrocarbon propane, C3H8, which is your gas, no? That reacts to five molecules of O2, which is also a gas, will yield to three molecules of carbon dioxide, which is also a gas, and four molecules of dihydrogen oxide, which is also a gas. So thank you so much for watching. No, those are the five types of chemical reactions.